Corporate finance practice problem using OneNote. We're going to use the annuity calculation to find the interest rate. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if have access and would like to, we're in the tab on the left-hand side. We're in the practice problems, and then down here on the 941 future value calculate investment rate of returns tab. Also note that when using OneNote, you might want to take a look at the immersive reader tool. Many of our presentations up top will have a mirroring item down below for the text files basically being transcripts that can then be translated to other languages and either read or listened to in other languages, that thereby being a good complement to the presentation items up top. So if you want to use that, take a look at it. Give us some feedback if you do use that. We're going to close this back up. Our information is going to be up top, and then we're going to use that information to populate the problem on down below. We're going to be doing a future value type of calculation we have seen in the past, but this time we're going to be solving for some other factor other than basically the future value, meaning we're going to use this formula to solve, in this case, for the rate. So we want to use the same formula, find the unknown, which will be the rate. So here's going to be our scenario. We have the purchase of stock. We're going to imagine we purchase 200 shares of stock at $20, that being the cost, 200 times 20 being the $4,000 for the cost of the stock. Then 3 years later, we sold the stock at a price of $31 per share. $31 times the 200 shares up top being the 6,200. So in essence, at this point in time, we purchased something for the $4,000. 3 years later, then we sold it for $6,200. What we would like to do is figure what are basically the rate of the return was on the investment. Now we can do this with a future value calculation. One of the difficult parts about a problem like this is trying to think about which formula you can apply that to. But if we think about our future value formula, we could say, okay, that's going to be equal to the present value times 1 plus the rate to the number of periods, n. So we can use that calculation and then solve for the rate. And that's what we're going to apply here. The way you might want to keep that in your mind is you might think about, well, if I was at the beginning of the time period and I was going to say that I had the $4,000 at the beginning and I was trying to project how much I'm going to make, then I might use a future value formula and assume the rate to project out what the future value will be, what I will be at when I end this whole thing off. At this time, we know where we started, we know where we ended, and what we're trying to find then is the rate. And so that's why the future value is the formula that you might think of, you might pick, and then of course you can then solve for it. So you could solve for it algebraically once you have the formula, meaning the future value now already known, plug in the amount of the 6,200 into it equals the present value, which would be the 4,000 times the 1 plus the rate being the unknown, to the number of periods, this being 3 for the 3-year time period, and then simply solve for the unknown. So the concept here would be that we're not going to memorize another formula for the rate here, just like we don't do oftentimes when using algebra, but rather just use the same formula, rework it, solve for the unknown. As long as there's only one unknown, then we can use our algebra to solve for it. I won't solve for it mathematically in that format. I'll let you run through that yourself, do the algebra. What I'm going to do is kind of give an idea of using that same formula and how you might use a tool in Excel, that would be the goal seek tool, to basically use the same kind of algebraic concept so that you could use the same function in order to find any of the unknowns. In other words, in practice, most likely if I scroll on down, you would want to be using the future value formula here. You'd be saying, hey, I'd like to plug this into the future value formula because I know that formula. I don't even want to deal with the algebra. Can I use this same formula and be able to do a similar concept, meaning if there's any of these items that are the unknown and I only have one unknown, can I basically rework this to solve for that unknown, or do I need to look for a different Excel function? And basically you can do that, but you got to do it with a goal seek type of feature. So we're going to introduce kind of that concept so that you can then do that in Excel. And then I highly recommend checking out Excel and going into that and using that concept there. So once again, if I go back up top, book problem, if it were a book problem, you'd probably have to solve for the formula. Let's now think about it in terms of of setting up using the goal seek by breaking that formula out into its normal calculation in like an Excel type of format, a table type of format. And we're not going to rework it algebraically, but think about how the goal seek works solving for the unknown. So if I put this into a table, it would be the present value times 1 plus r to the n. So I'm going to say present value is going to be the 4,000 that we have here. That's our starting point. Then we're going to take the 1 plus the rate to the number of periods, or n. So we have 1 plus the rate. This would be the unknown, this rate. That's what we do not know in the problem. Now, if we were to do this in a similar fashion as like a goal seek type of system, I would put some rate in there, like a 10% or something like that, so that we can then continue on with the calculation and then go back in and adjust that rate so that we can then come to our answer by basically trial and error adjusting that rate. This would be tedious to do if you did the math by hand, but easy to do if you have a spreadsheet. So then we're going to say that we have 1 plus the rate, that would be 116 about, it's rounded here, to the number of periods, which would be 3 in this case, to the power. So the 116 about to the power of 3 would be the about 1.54999, and so on and so forth. We can then take the 4,000 times the 1.5499 and so on, and we get about the 6,200 in this case. Now, if we used some other percent, then the answer percent, like a 10% here, we would get a number that was wrong, but we know what the end result would be. We would get the end result here. We would say, hey, that's not what we want it to be, and we could then adjust our rate, and we could do that manually, just plugging in different rates to come to the same calculation until we get closer and closer to the answer and finally get to the answer. If you had to do this by hand and recalculate it the whole time, that would be difficult to do. But for example, if I started with 10% up here and then tried 11%, 12%, and so on and so forth, climbing up progressively until I get to the proper percentage with an Excel worksheet, that's not difficult to do. And Excel has a function to do that, which is the goal seek function. So once you have this set up and you have your unknown here and all cells connected, instead of doing the math by hand, obviously the computer does the math, and you can then use goal seek to do the trial and error method to then find the number using a trial and error method, but the computer does it to figure out that it would be the 15.73%. So you probably wouldn't do this so much with the formula up top in this scenario. You could if you had the formula worked out in this kind of format in an Excel worksheet, and you might do that in other kind of example problems. But when using the function down here, you have the same concept, which would most likely be used in practice. You'd be saying, hey, I would like to use the future value function. I don't want to look for another function that is going to give me the rate. I mean, I might be able to do that, but I'd rather just use the present value function. And if there's only one unknown in it, have a similar concept to solve for that unknown. I can't rework the function because this is not a mathematical equation, but I can use goal seek in a similar fashion, meaning I could, for example, put the rate down here in another cell and simply put a test rate. I wouldn't make it 0. I would make it something other than 0 in case there's like a division by 0 or something that makes it a problem to calculate. Start with something like 10% and then use goal seek to change it. So the formula would look something like this. Future value is going to be the rate, which I would guess the rate down here. I would guess something like 10% to start with. Then comma, number of periods. We pick up the number of periods, which we said was 3. And then comma, comma, because it's a present value. Present value would be the 4,000. That's going to be our starting point. And then the answer to this, we know should be 6,200. If we chose something other than this percent, if we chose 10%, it would be not this number, right? And then we could start guessing, we could start adjusting this 10% upwards until we get closer to this number. Or of course, we could use goal seek to do that for us. So then we can use Excel to basically do that trial and error method, using goal seek to basically just force trial and error, but do it very quickly because it's a computer, to figure out what this percentage should be in order to get our end result right, allowing us to basically use the same method of solving for any unknown without having to find a different function in order to do so. So that's going to be, and then we can also see this concept in like running balance table. So you could also do this kind of same thing in a running balance table and try to figure out, your value. The 4,000 times something is going to give you then your running balance. The 4,000 plus the interest gives you your new balance, and then the 4,629 times the interest rate is going to give you this, and you get the prior number plus that will give you your new balance, and so on and so forth. You could use GoalSeek in a situation like this too, meaning you first estimate what the percentage is, 10%, and even with a table that's fairly complex, you can have a fairly long table that is all reliant on or all tied together with the percent, the cell we have down here, and still use GoalSeek to then figure out the percent there. I recommend doing that in Excel as well, just to get used to the tool. Most likely in practice, you would be using this method right up top, the formula, but we do work this in Excel as well, so you can kind of see how a longer format, a complex Excel worksheet, more complex, will have a similar feature with it. You can use basically GoalSeek with it. You can also use the same kind of method for the tables. So if you put this into the tables, note what we would know is this 4,000, and we know the end result is the 6,200. What we don't know is the amount that we would get from the table typically, right? And so we'd have to solve for that. We can actually solve for the amount that we would get for the table. So in other words, usually it's 4,000 times the amount for the table would get us here. If this was unknown, the middle number was unknown, we can then take the 6,200 divided by the 4,000. That would give us the 1.55. That's the amount that we would expect to see in the table. And so given the fact that we know that it's going to be 3 years, I can look for the 3 years area and that amount 1.55. It's not going to be exact because the percent is in between these two, but if we go 3 years here, I'm looking till I get to the 1.55. If I go up, keep going up, we're going to say, okay, there's 1.1249 and then 1.157. So and that's not right. I want to get to 155. So I'm going all the way out here. 155 is here. So 1.529 and 1.5609 is between 15 and 16%. And obviously it's going to be between 15 and 16%. Note the limitations of the tables. When we have a percent that's not even, 15.75, it makes it more difficult to use the tables. If you're using a book problem that's forcing you to use the tables, then they're probably going to make it an even kind of adjustment. You could then estimate, how far between the two using a ratio analysis, but most likely if the book problem is forcing you to use tables, then they'll probably make it even so you can find it on the table and basically back into the table once again, finding what the amount should be on the table, then go into what you know, which is the number of periods, and looking for that amount on the table that will then provide you with the interest rate.